let's go ahead and get started. We've got a number of people that have come into the meeting, and I'm excited to help moderate this panel. So the way the format's going to work, I'm going to ask each of our panelists to introduce themselves, give a little bit, 1 or 2 minute bio, and then we're going to go right to questions to make sure everyone has a chance to ask the questions that they'd like to. So with that, I'm going to start with Connie Kelly. Would you like to introduce yourself? Oh,
okay.
There you go.
Let's try that again. I'm Connie Kelly. I'm from Chicago. I went to Illinois Institute of Technology for all my schooling. I'm a biomedical engineer. I've wanted to be an engineer forever. Originally, I thought I was going to be a communications engineer and design radios for Motorola. I've never worked for Motorola, and I've never designed radios either. So life doesn't always take you where you think you're going to go, but biomedical engineering has been amazingly rewarding and a lot of fun.
Thank you so much. So next up, Charles Moritz.
Hi, I'm Charlie Moritz. I'm Director of Product Development and Research for a company called Cadillac Products in Troy, Michigan. So used to live in the Chicagoland area and worked for a company called Blatchford, but recently moved during the pandemic. My field is in acoustics. So I'm designing materials to make cars quiet. And before that, I spent a little over 20 years designing materials to make trucks and off-highway equipment quiet. I got there through degrees in engineering and music from the University of Cincinnati and a graduate degree in acoustics from Penn State.
Awesome, thank you so much. So next up, Robert Orlikowski.
Hello, my name is Bob Orlikowski. I work for the Nuclear Regulatory Commission. I've been there about almost 18 years now. I have a degree in chemical engineering from the University of Wisconsin. Out of college, I never really applied that chemical engineering degree. I actually went to work for the Bettis Atomic Power Laboratory and have been working in the nuclear engineering field since then.
Thank you so much. And next up, Karen Connery.
Hi, my name is Karen Connery. I am a chemical engineer. I received my schooling at the University of Notre Dame. I'm currently working in Burr Ridge for a company called Linde. Linde is an industrial gas company, so we sell oxygen, hydrogen, nitrogen, helium, the different industrial gases. I've been with the company for 23 years, and I'm working in research and development. And one of the interesting things that I'm working on right now is using carbon dioxide to help plants grow, like in greenhouses.
That sounds fascinating. So last on our list of panelists, Linda Valerio, excuse me.
Yes, I'm Linda Valerio. I'm a mechanical engineer at Fermilab. I started out not knowing what I wanted to do, but in my junior year of high school, my physics teacher noticed I was enjoying that class and pointed me towards engineering. And from there, I researched it and I just decided to go for it. I went to Marquette University, and through their cooperative education program, which I can talk more about later, I actually got to work at Fermilab before graduating. I spent 18 months working at the lab. I added a year on to graduation, and I wound up enjoying the lab so much. I've been at Fermilab ever since. And my main role at Fermilab is in the accelerator division. I get to design and fabricate the equipment that the scientists use to do their experiments. It's really fun.
Wonderful. So all the student attendees, please put your questions in the chat if you have any questions for our panelists. I'm going to start off by asking you all, what's your educational background and how did you come to this career? I know you all touched on it a little bit in your introductions, but if you want to go into more detail. I don't know, Linda, do you want to start us off?
Oh, sure, I can, sure. So I like to actually point out what Connie was saying earlier too, that don't always plan on everything that you think you know about yourself at junior high and high school level. So actually in junior high school, I didn't like science. And I say that now that I work for a science lab, right? So it frustrated me because I thought, well, you know, math is great. There's a discrete answer and that's perfect. And I loved that. science I felt frustrated by because you do the experiment, it doesn't always come out right, and there's no right answer, and it just made me so frustrated. But then I learned that it's the pursuit of the answer that's the fun part. And then when I got to physics, it made sense. I could write equations to predict what was going to happen, and that's when the math and the science connected, and I figured out, wow, engineering is really cool, and that it's an application of science using math, using attention to detail, and all sorts of just things that you're used to doing. And then engineering made a lot of sense to me, and that's kind of how I got started. And like I said, now I work for a science lab. So,
would one of our other panelists like to jump in and answer that? Connie.
I can jump in here. When I was 7 years old, I read a book called K. Everett Calls CQ. And the storyline was about a young lady who was in junior high who got her amateur radio license. And it sounded like so much fun. I found out what was necessary for ham radio. And by the time I was 8 turning 9, I had a ham radio license. And in getting the license, I had to learn some electronics and decided I really liked electronics, and ended up in all of the pre-college electronics, math, physics, computer programming classes that were offered in the Chicago area at the time, and ended up majoring in electrical engineering at Illinois Tech. And at the time, as I mentioned, I thought I was going to design more ham radio gear. Never happened. I do have a lot of ham radio equipment at home, including my ham radio.
You went on mute for a second. I don't know if you froze. Oh, I think
the standards which allow devices to be connected to computers that are involved with both patient care and diagnostics. So it's very rewarding, and you end up spending a lot of time in and around hospitals looking to see how things are implemented and making sure they're done correctly. It can be very rewarding to see how outcomes are being improved by the work that you're doing. It's something where you can see very tangible representations.
That sounds fabulous. Would anyone else like to talk about their educational background and how they ended up where they are? Oh, Bob.
Yeah, so growing up, I always liked math and science, and I had an older brother. We used to build a lot of stuff, and we did a lot of problem solving, and usually that problem solving consisted of trying to figure out how to build a go-kart with as few parts as we had on hand. When I was in high school, I had a teacher that really sparked an interest in chemistry for me. And that is really what led me to go into the area of chemical engineering. Coming out of college, my senior year, I really didn't know what industry I wanted to go and work into. I ended up in the chemical industry for a little bit, operating distillation columns. And then actually I got a call from a headhunter who took me down my current career path. He hooked me up with Bettis Atomic Power Laboratory. I worked with the Navy. They actually, on the civilian side, they provided the training that I needed to do my job. So it's been I never envisioned myself getting here when I was in college, but it's been a great road. I don't have any regrets.
Awesome. Charlie or Karen? Charlie.
Yeah, I'll jump in here. So I don't have when I was 3, I knew exactly when I wanted to do stories. So I did grow up right near Wright-Patterson Air Force Base, had airplanes flying over the house all the time. So thought it would be cool to learn how to design airplanes. So not knowing a whole lot about engineering, nobody in the family was in engineering, went to the University of Cincinnati, got admitted into engineering school. And then through cooperative in their co-op program. So you go to school for a year and then you alternate terms. I was assigned, I worked out with the Garrett Turbine Engine Company in Phoenix, worked with the Acoustics group, really liked acoustics from that standpoint. A lot of the other people in the group were musicians, so stayed in school for a little while longer, got a degree in music. After I finished up my undergraduate, went to Penn State, got my master's degree in acoustics, and then started working as a consultant and later on for companies doing acoustical materials.
That sounds fascinating. Karen.
Hello. So yes, I also found science and math very interesting in high school. And I didn't know about engineering, but we had someone come and speak in our math class and describing his journey in chemical engineering. I thought, oh, that sounds pretty interesting. So I decided I wanted to do that. But then I actually got a full scholarship to a school that didn't have an engineering program. I did have pre-engineering. So Rockhurst University in Kansas City. And so I went there, I signed up for the pre-engineering program. I took lots of, all the science and math that they had. And my idea was I was going to transfer to another school once I completed those requirements. But when I was talking to my guidance counselor, she's like, well, you have 4 years paid for here. You could stay, finish your undergraduate degree, in science, and then go on and do engineering in graduate school. So that's what I did. I got an undergraduate degree in chemistry and also with a minor in computer science. And then I went on to graduate school at University of Notre Dame and finished my PhD. And so when I got there, I had to take a number of undergraduate classes in chemical engineering that I didn't have previously, but I was able to do that. And I finished in 5 years. And then after that, I went to work for Lindy, Praxair at the time, and that's where I've been since for the past 23 years.
Thank you all so much. And again, to everyone listening, if you'd like to add some questions in the chat, please do. If you all could talk a little bit about what is a day in the life like for you at work? What's an average day at work? Feel free to either raise your hand or jump on in. It's always a little more difficult over Zoom. Charlie.
I'll not be shy here. I mean, usually as a manager, I spend my day in meetings, planning strategy and deciding, what the group is going to be working on for the next short term and long term, for the next weeks or for the rest of the year. But, for example, this morning we're doing a joint research program with a university. And so we spent an hour early this morning getting an update on that. There's a number of other programs going on within the company where we're looking to substitute materials because one material isn't available anymore. And so we have to get a status on the trials and making sure we're not shutting down customers and making sure we're supplying parts. So, car companies get a little upset if they can't make product, use up all those chips that they can get. And then other work that I have to do. I know we have strategic planning meetings coming up tomorrow, and I have a couple of technical papers for conferences that I'm working on. So that's pretty much my day in a life.
Bob, I think you had your hand up.
Yeah, so one of the things I do at least 50% of my day, probably in every job that I've had since graduating, is communications. That's either talking to people, talking on the phone with people, emailing people. This last year, it's been a lot of Teams meetings, video chatting. Right now, I'm a supervisor, so I've got 10 people that work for me. They review and issue licenses to companies that want to use nuclear materials. Previous jobs I've had, I've moved around a little bit in the NRC. I spent quite a few years as an inspector at nuclear power plants. I was actually stationed at a nuclear power plant up in Minnesota at the beginning of my career, and then later at the Duane Arnold plant in Cedar Rapids, Iowa. And that was a great job. That I rarely ever sat at my desk. I spent a lot of time out in the nuclear power plant, looking at equipment, making sure that the plant was being operated safely, making sure that the people that operated the plant were following all their regulations and meeting their license so that we knew that the plant was operating safely. It was great because, like I said, I rarely ever sat behind the desk. So it was great to get out and about and be active. And then before that, I mentioned I spent about 5 years working at the Bettis Atomic Power Laboratory. I was a civilian instructor for the Navy down in Charleston, South Carolina. They have two old nuclear submarines that they've converted to permanently moored training ships. And I spent a lot of time working with Navy sailors. They would go there to get trained how to operate the nuclear power plants before they went out to actually go stand watch and operate the nuclear power plants on operating reactors on submarines and also aircraft carriers. So that was also a very hands-on job. I spent probably half my time inside a submarine that was on the Charleston River. Very rewarding as well. Every 7 weeks, we got a new batch of students. So I got to instruct a lot of people. I had a lot of rewarding interactions with people as I got to see them come in and then 6 months later, see them leave with a whole bunch of knowledge.
Thank you. Would someone else like to talk a bit about what it is like in an average day? Karen,
Go ahead.
So an average day for me, lately it's been a lot behind the computer due to COVID, but one of the things I really like about my job in research and development is that we're selling industrial gases to many different industries. And in order to do that, we have to learn about the different industries. So I get to go take a lot of trips to different customer facilities to learn about what they do and to see what problems they have and how we might solve those problems. So while I do spend a fair amount of time, reading, researching on the internet or, communicating information to other people within my organization on, why we should try different projects and do different things. I also spend time, talking to people outside of our organization, visiting different facilities. Right now I'm working with greenhouses. So I've been able to, visit different greenhouses growing, lettuce and tomatoes and peppers and flowers and things and, learn about how they're growing the plants and what problems they have and what we can do to help them out using CO2 to help the plants grow, using oxygen to help keep the roots healthy, things like that. Safety is also a big part. If we're doing experiments, we have to do safety reviews and make sure everything, the industrial gases are handled safely, and both in our labs and when we do work out in the field. That's about it.
awesome. Linda.
I'll just briefly summarize. So my daily work is typically a combination of working with other team members. Some days I'm able to get some time that I do some independent planning, but often I'm involved in lots of meetings to do some designing and planning as a team, or so sometimes it's analysis. It depends on where you're at in the project and also where you're at in the team. Earlier in your career, you tend to do a lot more design work, and then later you tend to take on more managerial roles. And you're watching over younger engineers doing those design tasks. And in all cases, you're in technical things, and you do visit the job sites when it's useful to do so, and especially when there's no pandemic. But it's really one thing I like about engineering is you can make of it what you want it to be. So people who like to travel a lot can get into a field or into a career path that takes them on a lot of traveling. Or if you like to sit at your desk and do a lot of analysis, you can do that too. And you can kind of have that freedom based on, by having a single engineering degree, you have the freedom to have that flexibility and where you take your career with what company you work for and what you pursue.
Awesome. Thank you so much. Kind of a follow-up on that. We've had a couple people ask, what's the difference between different types of engineering, between electrical engineering, chemical engineering? What are the differences?
So I can start with what a mechanical engineer is. So it's a very broad field, and if you talk to all the mechanical engineers that are at this STEM Expo or even anywhere else in the world, we all get the same training, right? We're all trained in mechanical systems, so things like gears and linkages, structures, material properties, thermodynamics, which is how heat flows through things, fluids, which is water and air. You can vacuum as well, actually. mechanical engineering has a very, what I like to call a toolbox. You learn a lot of different things and you know a lot about all these things, but you're not necessarily an expert at all of them. You develop over time your area of expertise, and that's the tools that you use the most, if you will. But you still have those other tools in your box when you need them. And that also helps you work with other types of engineers. So I will work with electrical engineers and civil engineers, and I know biomedical often intersects with both mechanical and electrical. So there's lots of things that intersect with different engineering types. So that's the one I covered is mechanical, but I'm sure everyone else can expand on theirs.
I would say chemical has a lot of the same base courses, but then also you have the chemistry and the reaction engineering as well. One of the questions I often get asked is what's the difference between a chemistry degree and a chemical engineering degree? And so chemistry is more, you know, you're making chemicals in the lab, whereas chemical engineering, you're kind of developing processes. So in one case, you might be making a new chemical. The other one, you're actually developing the process to manufacture that chemical, like on full scale.
Awesome. Connie, it looks like you wanted to jump in next.
Hi. I noticed a lot of questions coming through about engineering study fields. One thing that the majority of the engineering schools, at least the ones I know of, have, is that for the first couple years, everybody takes the same thing. You're in what's called Common Core. Everyone takes math, everyone takes chemistry, everyone takes CAD. So up until your junior year, when you get to specify, you have the same exact foundational training. And then when you get to junior year, you're usually asked to say what your specificity is going to be. And even then, you have some electives. Some are general education electives and some are other engineering electives. For example, if you want to go into robotics, you'll have some mechanical engineering, you'll have some electrical engineering, and you'll have some computer science courses. So you'll have kind of an amalgam of different programs. So it's really easy as you're going through to see whether or not something is really for you, and maybe you wanted to go into one kind of engineering, and then as you've gone through your Common Core curriculum, you'll see other things that really interest you a lot more. So you haven't really messed up and have to go back to square one and retake everything. Everything in the first couple of years is your foundational course block, and then even when you go to specify, you can move around and take courses in other disciplines and make changes to your curriculum. It's really, the one thing that engineering has is a lot of fluidity. It's really easy to move amongst different disciplines. And especially as things are getting more and more interwoven these days, and you need more than one discipline to complete a project, it's really easy to move around in disciplines. I know I noticed a question in the chat about aerospace engineering. You know, whether it's better to major in aerospace or in mechanical. Well, up until junior year, and even in junior year, a lot of the classes are the same. In fact, at IIT, it's called aerospace mechanical engineering, which I never understood, but I was in electrical, so I didn't really pay that much attention. So, you know, don't get hung up on labels. Pay attention to what you'd like to do and where your interests lie, and then follow that series of courses that take you there.
So we had another really great question in here. Let me figure it out, or let me find it again. What personal characteristics do you think each of you possess, each of your positions require to be successful? What's the most important characteristic for success?
Curiosity.
Yeah.
I would say attention to detail.
Charlie, it looks like you have something to say.
Yeah, you know, I think in any project, right, you have to be able to work as a team, right? So you want to be a good team player and bring a lot of good ideas to the group, but also you need to be humble. You know, I think no matter where you are in your career and the more you learn, there's always somebody out there who is living today or you lived in the past who knows a lot more than you did. You know, it always seems that way. I think those things, and then the ability, like when you really need something that you really have to push, you know, internally we call that, you got to push the up button. You know, if it's really urgent, you have to really let people know you need this done and need their help. You know, otherwise everybody's always busy and has a million things to do. And if you don't push when you need to, then people don't respond. So there's a whole gamut of skill sets that you have to have.
Well said. I agree.
Yeah, I'll jump in. You know, to me, communication is very important. Like I mentioned, I spend a lot of my time communicating. And the biggest thing, you know, communication, talking is half of communication, the other half is listening. So being able to listen to other people, listen to their ideas, and truly listen, not, you know, look at them and think about something else. That's really important because that's really where a lot of the work happens, is in the dialogue between myself and the other person or persons that I'm talking with.
So, oh, sorry, go ahead.
I was going to say, engineers are problem solvers. So engineers look at things and immediately they start going through a mental checklist. How can I make this better? What would happen if? So you need the curiosity to try something and be able to fail as well, because failure is part of the process. But the idea that you're trying to solve a problem is what every engineer does every single day. Work towards solving a problem.
So we have, oh, Charlie, did you come?
I just wanted to jump in. I know there was a question that came up in the chat about taking up a trade as well.
Mm-hmm.
And I just, while we're talking about engineering, I know there's a broad, engineering covers a lot of ground, right? You can get a PhD in engineering, you can get an associate's degree in engineering, you can get a bachelor's degree in engineering technology, depending on how applied you want to be. And we hire a lot of people that have a applied degree who run injection molding machines and extruders and other pieces of equipment and know robots inside and out, as well as people who understand the theory behind the control systems that operate everything. So at different levels. So there's a lot of different ways to be involved in engineering.
So I think we have about 5 minutes left, and this isn't a question for chat, but I'm wondering, in 1 minute, can each of our panelists give their best advice for high schoolers now? What do you wish you could tell your high school self, knowing what you know about a career in engineering? What do you wish you'd known for our high school students here that are hopefully going to pursue careers in STEM? I don't know if someone wants to jump in, but I'm going to start calling on people. So, Karen, what advice would you have for our high school students?
Oh, yeah, just be very, pay attention to your curiosity and what you're interested in. Ask a lot of questions, do a lot of research. Don't be afraid to fail. Yeah, I think that's what's at the top of my head.
Don't be afraid to fail. I know is a big one. Linda.
Yeah, I can go next. I along that line, yeah, I would say be prepared for continuous growth. You're not just going to get through engineering and get your degree and be done. You're going to learn continuously on the job. You may switch what you do in the process, and that's okay. You're likely to start out doing a small component design, and then you're going to grow into larger components. So you might switch off and go into R&D and look for new technology. Or you might get into a certain point in your technical career and then maybe switch over to a management role. And then you just never know where you're going to end up. So be prepared for that. And that's actually the exciting part of it, is you're never done.
Bob.
Yeah, I'll just say, one, it's okay to not know exactly what you want to do. I had an idea that I wanted to go into chemical engineering. I honestly didn't know a whole lot about what chemical engineering did or what kind of job I could do with my degree, but I know that I liked engineering. And as I mentioned, I really enjoyed my chemistry class. I thought the two were a good mix. So, and kind of like, Linda said, you're gonna change jobs. That's a great thing. I recommend changing your jobs. Nowadays, it's pretty rare for somebody to join a company and make a career out of it. Just enjoy the ride. There's a lot of unknown. Um, kind of look at your career as a problem that it'll get solved along the way.
Connie, what advice would you have for your high school self?
Well, as long as you've got the grades for it, don't get talked out of it and don't succumb to peer pressure who's like, oh, engineering is hard or engineering is for geeks. And to the girls there, if a guy tells you, well, I can't date an engineer, my advice is goodbye. A lot of the kids that, well, grade school, because I went to an all-girls high school, so it was totally different. The kids in grade school who said, oh, you want to be an engineer? Well, I make 3 times what they make now, so don't listen to them. They're just jealous.
As someone that went to a women's college undergrad, I really appreciate the experience. Charlie, what would you tell your high school self?
Yeah, I think freshman year was a lot more work than I had expected. I think college is just there's a whole new level of expectation, and it's going to be a lot of work. I mean, I think on a good day, I was trying to do 8 hours of homework kind of a day. So you have classes during the day. So it was much harder than I expected.
It is 7:25. Thank you all so much. This was a wonderful panel, and I really thank you all for being here. For the students here, we have another panel coming up in a minute, but also please feel free to explore the booths. It can be a little intimidating because as soon as you walk in, you're kind of in the spotlight talking to the person there, but they're very excited to get a chance to talk to you. So please explore the booths, get to ask all of your questions one-on-one, and I know a number of these panelists will be at their booth to talk to you. So have a great remaining STEM Career Expo, and thank you so much.